Hi guys, welcome to Gosa Designs channel. In today's video, we are going to talk about how to draw or how to model a 3D spiral staircase. Okay, if this is something that makes sense to you, kindly consider subscribing because I'm going to share some of the techniques that I use day in day out to make my work more productive. Is that right? But in this particular video, we are not only going to talk about strategies, but we are also going to talk about step-by-step guide that will enable us to model the entire staircase. Okay. So also, if this is your first time on this channel, kindly consider subscribing because I'll be sharing most of these similar videos. And also, just do me a favor by sharing some of this video to your friends so that we can all enable the dissipation of the knowledge. Okay, so let us start right away. Now, as a spiral staircase, there are some critical parameters of a spiral staircase that we need to know as a designer right from the beginning of the modeling. Okay, so the number one will be the diameter of the staircase. So let's say, for instance, in our case, the diameter of the staircase is, let's say, for instance, 2,150, and then the diameter of the post, there is always a pipe in there is always a post in the middle of the staircase that holds the this in place. Okay, that holds the staircase in place. So let's say the diameter of that post is 150. So to draw that, what I'm going to do is enter 150, enter. Let's say the thickness of that pipe is 8 mm. So O enter, which is offset 8 mm, enter. Okay. Now, with that being said, the next parameter to consider will be the total height of the staircase. The total height of the staircase. Let's say, for instance, in our case, the total height of the staircase is 2,700. Okay, 2,700. Now, what do I do with this height? Now, based on this height, I'm going to determine the number of threads that I'm supposed to use. Because ideally, the height of or the height between two consecutive threads or the rise of the staircase should range between 150, 180, 170 up to 2. But beyond 200, 250, when you are climbing the staircase, it becomes a little uncomfortable. Okay, so we based on some of the code provisions, it is always best to stick around 150, minimum 150. Let's say so. In this case, we are going to consider, for instance, how many steps. So I have a total height of 2,700. 2,700. Let's say divided by 150. That will be 18 steps, which is a little more, too many. So what I'm going to do is 2,700 divided by 8, divided by 180. Then it gives me steps, threads. Okay. Some people say steps, but the right word is thread. Okay. So it means I'm going to have 15 threads at a height of or at a rise of 180 mm. 180 mm. Okay, so that is that. Then I think these are some of the um, critical parameters for a designer to know before you begin modeling the staircase. Okay, so we talk about the height of the staircase, the diameter of the staircase, which is the distance from here to here, just for you to have a fair idea about the space available for the staircase to fit in. Is that right? Now, apart from that, we also talk about the thread. The thread, the width of the thread. In this case, the width of our thread annotation is the width of our thread be from after the pipe here. Ideally, it should be within the range of 1 meter, 1,200, but the minimum to consider should somewhere 850. Okay, because below that, when we are climbing it, it becomes a little uncomfortable. So let us know that. Now, let's say, for instance, the first thread begins from here. So because my platform, let's say for instance, I'll be climbing the staircase in anti-clockwise direction. Okay, let's say in this direction. So it means my last thread will be ending here. So I have to make sure that the trick is that I have to make sure that the end of the last thread will be perpendicular to the platform. So right when I leave here, then I can just climb the platform as in access the top or the level which is at 2.7 meters. Okay. So now what I'm going to do is that I'm going to divide circle, the circumference of this circle, 15 parts into parts. So what I'm going to that I will just select this line, type array with the aid of my keyboard, array, then I'll specify, AutoCAD will prompt me to specify the center point of my this, my array. Yes, yeah, then a dialog box open, specify the number of items. Let's say for instance, I want 15 items. Yeah, we said 15, enter. I'm here now. So now I can just use the command explode to explode these lines, or better still, R enter, X enter, then it exploded. Okay, so it means my first thread starting from here. Sorry, it's my first thread. Okay, and my last thread, this and this. So the first and then the from the top view that we are drawing now, the first and then the last thread, they share the same beginning and then end line. Is that right? So I can just delete the remaining thread lines. Now, before we delete it, we need to make sure the distance station, this distance print somewhere, okay, for the width of the thread. Okay, so this is 39, which is okay, which is okay. This now I just have to delete this by the aid of E enter. I've deleted them. What I'm going to do is that I can just copy this. I can just trim it. CR enter. We in some previous videos we covered some of these basics of AutoCAD 2D. Okay, so if you haven't watched that video, I am pleading with you to go and have a look at it so that we can all be on the same platform. Is that right? No. Now I have this. I can just select all. Okay, enter. Enter. Then I have joined line to be. Now all those single lines are converted into a polyline line. Okay. What I'm going to do next, just want to draw the thread for now. Let's say for instance, I want to offset this. We want to make this out of a sheet of a out of a 3 mm thick. Go enter 3. That's still. Let me just the interface. Press pull down 3 mm length of the sheet. What I'm going to next, I'm going to draw maybe L angle. But then I need to change my U L down. So let's say I want to make a bend of 40, 30, 30. Okay, you can just join it. After that, go enter. Okay, now control it. Then after that, I can just around this. RO enter. M enter back. So I will select it. Command. Set the path. Repeating the same again. It's not actually how I wanted it to be 10. What I'm going to yeah, how I want it again. Now I have a bend for 40, 40 back, SE isometric. What I'm going to do is that I can just I can simply mirror this, or maybe I can rotate it, any of them. But before for the rotation, I need to make the 3D rotate command, 3D rotate. So I want to rotate it about axis, the red one, for instance. Now I need to make again 3D rotate is important about again. Then we are good to so I can just place on it. What I'm going to do is that I need to rotate this back. Before I do that rotation, I need to make sure it coincides with this one. Before I do that rotation, I need to make sure that the plane of the XY plane is parallel to the top of this surface. Okay, so you see S on my X here, Y here. I'll just let it hit RO. I'll specify this point of rotation. Then from there, I need a reference. So REF, enter. I'll specify this and point. Then my thread is nicely fitted. So with this, I'm good to go. Don't forget to always make use of Control A, Control S for the saving. Okay. So let's say I want to save this on my desktop with the name of Spiral Stair. Spiral Stair. Okay. Save. Now also I want to change the properties of this SOPR in terms of color and some other things. For instance, I want to specify this color. Any color of your choice is fine. I like this, so I will be setting this color for a thread. Now my thread is ready. What I'm going to do now, just move the beginning. My first thread ready. Okay. So let's go back to S isometric. So now what I'm going to do, extrude 5 or press pull. Okay. The height of the pipe of the post is 2,700. Okay. Yeah. Now what I'm going to do next, what I'm going to do that I can just convert it into a block. Very important to convert this into a block. I will place it back. Later delete. There are two here. Okay. Now we make use of selection already there. I just have to activate selection. Yeah, filter object. Now it's off. I need to on it. Solid drawing or component. Already deleted that. Okay, now because we need to make a provision for handrail to right away from this one. So what we are going to do is that our this thing is starting from here. The first thread is starting from this point. So let's say for instance we want the thread, the the handrail be at the edge of the first thread. Let's say for instance it's a pipe down, down, there may be a pipe of diameter 100, a pipe of diameter 30 mm. You use that type of handrail, or let's just use a pipe of diameter, let's say for instance, uh, 38 mm at a height of the height of let's say 900. What I'm going to do that, let's place this pipe. Better I change the visualization effect into wireframe a little here for visual purposes. So the pipe is here, pipe side by can move in side by let's say 38, 38 divided by 2, 19. I'll go backward 19 just to make sure that the thread is on the DC. The pipe is on the thread. Doesn't really matter. Just move backward. Let's say 20 mm. So now this is done. What I'm going to do next is select both, select both array, polar array, or specify the center. Now I want number of objects from 5. Okay. Then after that, I can just select it and explode it. Okay. Now my first thread was there. Don't forget what I'm going to do. I will select in the remaining one. What I'm going to do is to shift raise this one each step by step. Okay. So what we are going to do is that we are going to end this video here, and then in the next uh video we'll be continuing. Okay. Thank you so much, and see you in the next video.